All right. Good morning, good afternoon, good evening, depending on where you're listening from or when you're catching the recording of this. Welcome to our session called A Step Closer to In-Totally Secure. Looking forward to talking to you about some awesome supply chain security features and open source projects. So we'll go ahead and get started here with a brief introduction. Huge credit to Tom Meadows, engineer I work with at TestifySec, for putting these slides together. He has way more creativity than I do, and he has a lot of talent for putting these things together and did a lot of hard work on them. He's an open source engineer. He spent a lot of time working on Witness, which is a project we'll be talking about today. A little bit about me. I'm the director of open source at TestifySec. I always tell people, just so you know, it's a startup. About half of us are directors, so don't get too caught up in the title. And I spend a lot of my time working on Witness and Archivista, as well as a few other open source projects. And so building secure software, how does this all work? What have we learned? Well, a long time ago, we all started learning about supply chain security and how we can build secure systems. So how do we do it? Well, we use a bunch of other libraries, open source. We get these things from all over the place, wherever they may be on the internet, on USB drives we find lying around in parking lots, wherever it is we decide to find them. And then we want a repeatable process, right? So we automate the build. We'll go ahead and go through and use something like GitHub Actions or some other CI/CD system. And we do code reviews, right? Everybody does very thorough, deep inspections of all the new code that's written. You would never just glance over anything and give a look good to me without a very detailed introspection. So everything's good, right? Well, it turns out in our GitHub action, we use Go releaser in order to create a release of a Go binary. And we build it. We set it up. You can see everything here for the GitHub action, runs as a job. We check out the code, we set it up, and we release. Everything's good, right? Well, you'll notice there is a slight typo here. And in the project we're getting Go releaser from doesn't have an E at the end. So this is a actual org that Tom created for a short while and then shut down just for the purpose of having a demo like this. And now we can see here, when we actually run the build, there's an unexpected echo message here. You got pwned. So this is a problem, not a good thing. Game over. So what do we do about this? Attestations are the answer. So what is an attestation? In this case, you can see recording an attestation of this build process. You could capture things like what commands were run. And so in this case, the commands that were run were echo, you got pwned, and go releaser. So the typo squatted version of this really didn't do anything other than just print out that message. So this is kind of scary. What are we going to do? So now here, we can actually capture this information, put it into base64 encoding, because everything nowadays is base64 encoded, and then sign it, because without some sort of identity of knowing who it was that performed this action, there's not a whole lot of value to it. It can be modified, the content, and so that's an important part of this. So this is where Witness comes in. After we have this attestation created, we can verify it. We can have a policy. We can use the attestation. We can use a key, public key, to ensure everything is what we expect it to be. So we talked a little bit about attestations. There's a bunch of other things that can generate attestations as well too. Salsa, the supply chain levels for software artifacts, has a bunch of tooling around generating attestations. Cosign is a project that can generate attestations. Sift, Tecton Chains, Chainloop, there's the projects all over the place that are creating attestations. And who can verify them? all of them. There's a lot of different ways in which to verify these things. So what's the standard? How do we actually go about doing this in a way that's consistent across all these different tools, all these different mechanisms of creating and consuming attestations? And that's where in-toto'lly is the answer here. And in-toto is the specification. They got a great logo here. And one of the things you may want to do is write a policy. And so in policy in Toto, sort of nomenclature is a layout. And that lets you define your supply chain. So throughout this, you can have layout that has things like the steps that are expected in your supply chain, what materials should be passed as inputs or outputs. Everything should be signed and is something that you can verify. And so what are the things that you want to attest to? What's the content that's really useful? And so for this, we have in-toto statements. And the statements are really a wrapper around these different types of standard formats. And so here you can see a concept of subjects, which is relationship to the environment, a relationship to an artifact that's produced as a part of the supply chain, or other things, and a digest, so you know how to uniquely identify that. And then inside of the bottom here, the predicate type, that's where you really get into the contents of the set of information that's being captured. So a few examples, you can have signed, tested SBOM, software bills of materials. You can create a more general link format, which is the original format of attestation. You can have one for releases. NPM can generate release attestations now. Salsa is another common one for generating provenance format. There's more and more being worked on right now. And I think we'll continue to see this expand as people find more uses and more ways to validate all these different pieces of metadata. So what does it look like? This is from the in-toto attestation specification repository. Here you can see around the outside, the envelope. This is what holds the statement inside of it. The format most commonly used is called DSSE, D-S-S-E, and this stands for Dead Simple Signing Envelope. And so in security, the most secure thing is usually always the simplest because there's less error prone, less opportunity to make mistakes. The more code we write, the more bugs there are. So the less you have, the better in many cases. So inside of that signed envelope, you have the statement that we talked about before, listing out the subjects and the references to those, and then the predicate type and the information captured in there. All right, so this is a lot. This is a lot for people to understand. How do we actually make it useful? How do we make it easy? And so this is where our projects, Witness and Archivista, come in. So Witty, you can see his powers are observing, attesting, signing, verifying. But man, it's tough because he's so cute and adorable. And we do have some cool swag if you ever see us in person for the project. The other part of this is Archivista, and Sandy is our mascot for Archivista, and Sandy's main role is to be able to store those attestations, retrieve those attestations, and there's a GraphQL API to be able to query those attestations and really help form those chain links to be able to know what happens from the beginning of the supply chain and follow it all the way through to the end. All right, so what are we going to do? How are we going to actually avoid this scenario that we talked about here in the beginning? So here, a wild hacker appears. The hacker, you really think that you can beat me? The wild hacker uses a typo squatting attack, and it's super effective. So what do we have happening here? We have the hacker creating this typo squatted GitHub action, and we build a container image that has this. It's been compromised in some way, and we fail. But what if we create an attestation for this? So witness can actually wrap around this process. You don't have to do anything else other than say witness run and then the name of the thing, and it captures all this metadata about it. You can see the commands listed in here about what actually happened during this build process. And so we're going to enable Archivista so that we can send and store this attestation that's been created. And now, after we have all this information, we actually want to use this container image. Let's go ahead and verify it so we can have a very simple policy. In this case, we found out that, hey, the commands that we got that we expected don't actually match what was in the content. So we only expected go releaser to be the command that was executed, not an echo command. So how do we tie all this in to that final step, actually running these containers or workloads in production? And this is where Archivista data provider comes in. And so this is a gatekeeper external data provider. And what it can do is query Archivista for you. You can have policies created as CRDs that are part of the data provider. And then you use all the normal features of Gatekeeper. You can set constraints on what namespaces or what types of entities you want to restrict pods or deployments or different things like that that should have these policy checks run against them. All right, so let's see, what does a real world example of this look like? So first, we're going to take a quick look at our pipeline that we have here. And so with this, we try to make it a lot more complex, realistic, and show kind of different pieces here. And so this is our software factory demo repo. You can see it's a simple Go container image that gets built. We do some formatting in the beginning. We run go format, go vet. We do some linting of the Docker file that we use in here. Obviously, we got to have our unit tests. We do some static analysis, looking for other issues that might be in the code. Then we build the container image. We build the binary. Depending on what it is, you want to have different deployment formats. We use BuildKit and the GitHub action for building the image, which those of you who've used it know you can't push it to the registry and save it locally at the same time. And so we have to have two different steps for this. And then once we have this container image, we want to do all the other security best practices. We generate a software bill of materials. We scan it for vulnerabilities. We want to scan and make sure there aren't any secrets that get embedded into that container image somehow. And then at the end, we want to actually verify this. In a practical sense, this verification might happen here at the end of the CI/CD pipeline to give developers earlier feedback, or it might happen at deployment time, which is the next thing that we're going to look at here. So we want to have a policy that really captures all of this and ensures that the things we expect to happen actually do happen. So this isn't a great human readable format or anything like that, but it gets the job done. And we're working on a lot of improvements in the space to help make this easier. So you can see we have our formatting step listed here. We have our vetting step, our linting step. And for each of these different steps, you can specify the name of the step and the types of attestations we expect. And so here we expect to capture environment information, get information. The materials are all of the inputs to the job. The products are all the things that come out of the job, and capturing the commands as well that are executed. And the other part of this is the functionaries. Who was it that we trusted to do this? And so in this case, we leverage a lot of the things that the SigStore project has to offer. So down here, we can see the extensions for a SigStore full CO certificate. We want to make sure that the identity that signed this is actually a GitHub Actions workflow. We can look for a specific SHA of that workflow itself. We can make sure that the repository where the source code came from is the demo repository that we expect it to be. We expect a particular workflow here, which is a reusable workflow, to be the one actually doing all of the signing. And we can point to the digest of that specifically. The other thing is we want to make sure that these runners are, in this case, the GitHub hosted runners. We want them to be secure, hardened environments so that people can't tamper with the build and affect the content of these attestations. So we do that throughout all these different steps. There's a few other things we can do as well too. And so you can see here for the build image, we have an additional attestation, which is our salsa provenance. And so that's something that's becoming more and more of a standard. We see in a lot of different areas. Homebrew is starting to have support for salsa provenance, NPM. A lot of different ecosystems out there are building support for this type of provenance, which is gives a very strong guarantee around the origins of the software that you're consuming. The other part of this is validating those commands that we talked about. And so here is an example of how we do that with a pretty simple rego policy, which we base 64 in code to put in here, where I broke this down a little bit here for you to be able to see. And really all we're doing for this linting step is ensuring that the command we run is header-lint with passing in the Docker file we expect. It creates a serif document as the output. And here we can see if it doesn't match that, it's an unexpected command. You could put ignore flags in here. You could completely remove it. You could do all sorts of different things to modify this. If you're a developer, you have access to the CI/CD pipeline. Even if you get a PR review or things like that, it wouldn't be unheard of for something to change here that's not in compliance with what you expect. All right, so now we have all of this. Let's see what happens when we actually go to deploy it. So here you can see we have a pretty simple setup here. We got a kind cluster running, Gatekeeper. We have our Archivista data provider deployed. Inside of this, you can see we have some CRDs for policies. And here we have our policy sample. And if you look at this, it's mostly going to be the policy base 64 encoded. And then we also have our constraints. So we're going to deny images with no passing policy. And we can see here, we're applying this to the default namespace. And we have our constraint template, which in this case for our external data validation is really pretty simple, and it simplifies a lot of the things that Gatekeeper has to worry about. So in this case, all we do is a call out to the Archivista data provider to validate that this image is something that's in compliance with the policy. So we'll go ahead and give this a try and see what we can do. So if we look at our deployments again, we can pull up the logs for the data provider here, and we can clear these out just so we have a good sense of what's going on right now. And do our run of, we're going to start out with a test image. So we recently added support in Witness for salsa provenance. We have this test image from earlier that didn't generate salsa build provenance. So our policy says we expect that now. And in this case, the image doesn't have any attestations for that. So we'll go ahead and try and run this. Right now, it's going to go and it's going to look and see what the digest of the container image is, try and find a set of attestations that match that policy by querying Archivista. And in this case, we can see policy verification failed. It was denied because we didn't have a set of attestations that match the policy. So now let's try that with our updated container image. So now we'll go ahead and run this, and you can see as this goes through and process, we get a different reference to the container image, and now we get a very different response. We actually get the information about the container image. I did a dry run here just so I don't have to keep changing the name every time I run the test, and we can see though from the logs, the response we get here is the verification succeeded. And the other important part about this is we capture all of the evidence. And so here are, we use something called a gitoid, which is a get identifier to reference the all the attestations. So you can go and query Archivista later on and retrieve all these attestations, examine the evidence, and then you can also create another attestation for the verification itself called the verification summary. And then this will allow you to do things like cache policy decisions and reuse them later on for a certain amount of time. And then you can expire those validations. So this kind of shows you the process of how we're able to track all the way from source code to the container deployment running in production, and ensure all the different steps and expectations we had about that supply chain were actually met and adhered to. And so we'll do a quick transition back here to our last slide, and you can see that a couple of QR codes here for the projects, and love to have you join the community. Follow up with any questions you have about Witness or Archivista or in-toto. There's a lot of fun and exciting things going on here, and it would be great to have you as a part of the community or as users of the products. So thanks for your time today, and hopefully we'll cross paths soon.